All right, so this time we're gonna go ahead, we're gonna reverse what we just did. We're actually gonna go from number of molecules all the way back over to grams. All right, so let's come up with a question here. Let's do something a little bit, I'm gonna stick with water. How many grams, and this could be given to you by what is the mass, what is the weight. That's all gonna be interchangeable for our purposes with grams. All right, so how many grams of water, H2O, are there if you have an obscure number, 25.2 times 10, I don't know, to the 27th molecules. All right, so here we are going from atoms, that's where we are in our directory, atoms, and now we're going to go to grams. Cool. Well, I have grams in the equation, so I'm definitely going to need molar mass. That's this guy. And I'm definitely going to be moving from atoms to the mole, because the mole is going to talk to grams. So this is another two-step problem. I'm going to go ahead and calculate for water, which you should get around 18. I'm pulling that, there's 2 hydrogens, 1.08 or 1.01 depending on your periodic table. And you have 1 oxygen, 16.00 or 15.99. But for me, I'm using a rounded periodic table, so 18.02 grams H2O in 1 mole of H2O. All right, and this one's always going to be the same. If you got a mole of something, you got 6.02 times 10 to the 23rd. So let's go ahead and get started. I'm given this number, so 25.2 times 10 to the 27th. You see, I'm not being afraid of this exponent. You just put it on in there. Molecules, H2O. Okay. So squeaky. All right. So these are my 2 conversion factors I've got here. Now, I am going to start not with grams, because I have nothing to do with grams. Grams doesn't talk to number of anything. But down here, I'm looking here, and I see that. So I've got molecules. So I'm actually at the item part of how many items are in a mole. So I'm going to have to use this number. And this number is going to go on the bottom, because that's where atoms molecules is. So I get rid of molecules. So I'm going to pop him right in here. 6.02 times 10 to the 23rd. And of course, the mole is still a part of this. 1 mole. Okay. All right. Now I want to get out of moles. Well, I've already used this guy, so, and by the way, I know that I want to go to grams, and I can see grams right here. We can see the light at the end of the tunnel for this problem. We got moles, so we're in moles, so that actually works out really nice. So in 1 mole of H2O, right, I have 18.02 grams of H2O. And that's just pulled right here. okay? So if I look at this, and I really should put molecules here, because that's really what we're talking about. So, right here, molecules is gone, molecules is gone, all right, mole, all right. So our setup is solid here, and my answer is in grams, so I'm going to stop here. This is the end units as far as setting this up. I'm not going to take any more steps here, all right? No more steps, no more conversion factors. I'm where I wanted to be. My destination is here. So all that's really left here is to crunch the numbers. I'm going to do my math step right here so you can know what I'm actually putting in that calculator. So we multiply across 25.2 times 1 times 18.02. So you got to have your calculator handy. All right. 0.2. And, oh, I'm going to put parentheses. Now remember, when you put this in your calculator, right, I'm literally going to use the EE button for this part, E27. So parentheses, 25.2 times, oops, I want to write times there, 25.2 EE 27, close my parentheses, times 18.02. Okay. And you should get this number right here. It's going to get bigger because you're multiplying. That's okay. 0.54 times 10. Remember to write that times 10 back in there. To the 29th power. Okay? That's the multiplying part of it. And then this is just times 1, so it's going to be the same thing. So I'm going to take my answer and I'm going to be dividing it by 6.02 times 10 to the 23rd. I'm not writing my units because I'm really just crunching numbers at this point. So I take that parentheses 4.54. All right, close my parentheses. Oh, no, I'm not going to close it. 4.54 EE, don't forget that part, 29. Close your parentheses. Divided by, I'm going to put parentheses around this too, 6.02 EE 23, close my parentheses. And you should get a big number here. That's expected. I'm going to go ahead and put it back into scientific notation because you really should. But if you didn't, that's okay. You're just going to wind up having a huge number. And that, you know, that 152.82, and I'm getting this huge number. Okay, and we'll see if that makes any sense here in a second. Let's make sure. It's divided. That shouldn't, that's not right. Okay. Yeah, I was looking at that. I'm going, you're dividing. I multiplied. So I'm looking at this going, okay, you've got a big exponent over a little one. Yeah, so this is what happens if you make sure that you do the right thing here, the right function. So it should be 75.41. And I'm actually going to round it right here. So this actually becomes a 2. That's why it's important to to logic yourself through this. Also, that would be a lot to weigh out on a triple beam balance in the back, right? All right, so this should be in grams. It's a large number over a small number. Okay. So I know that there's going to be more than one of it, but it shouldn't be like thousands here. Okay, we're not that many powers off. Okay, grams, and what are we talking about? We're talking about water. So we've got grams of water. So This means that if I wanted to get this many molecules, theoretically I could do all this, and I could go to the back and I could weigh this out, and this amount would be equal to the 100th place to this many molecules, which is pretty cool that you can actually do that. All right, that is how you go from, we went from grams to moles first, and then we also went from atoms to grams. Tips, anytime you see grams, you're gonna need to use